There we go. Remember, it's not enough to just have the answers. Make sure you put how you got them. Okay. I know that most of this, now that we got all the formula business, most of it's just calculator shortcut. One-shot it. Write on your paper what you put in the calculator. Because remember, today's quiz every year, without fail, every semester, there's at least one kid that does half their tests wrong because they're in the wrong mode. If you at least put everything on your paper correctly, and nothing's remotely close, if I can double check that you were just in radians and then just be one off instead of multiple. Okay. I'll give you credit for what you know, not just a slip of the calculator. Holly, you had said you're gone Monday. Who else? You?
And Maddie.
Okay. Anyone else? Okay. Who wants a scone? I thought it was chocolate chip, but I smell blueberries. I just stole it out in the lounge. Mm-hmm. Putting little chunks of fruit in baked goods, just that texture ain't right. Okay. I know this is mostly calculator mojo. I see a couple still typing. We need more time or a little bit? Okay. Hope you all feel reasonably well versed on this. Again, it was all review from geometry. There was supposed to be an assignment yesterday, but just life said no. Just plain forgot because stuff and things. The last two examples that we didn't get to are beyond easy. If you want to go through them, go in an old video, look. It's like, it'll take you 10 minutes. It's just two formulas. It's area by law of sines and area by Heron's formula. You literally just jam stuff in a calculator. Like, it's so easy, and I know that you did it. You should have done it in geometry. It is just formula plug and chug. Okay? Next time you may see it, they'll give you the formula. Okay? It's that simple. So I'm not concerned about missing those two parts yesterday. I do want to make sure that we knock out Chapter 7 next week, because that is critical to going on to trig. Another one of those things where you should have been exposed to it in Algebra 2, but our Algebra 2 isn't actually Algebra 2. Okay. Seeing the last couple bits of typey. I suppose I can give you the review. Just gonna have to bear with me today. I'm put a blanket veto on anything resembling brownie points. Found out why the previous night was so bad. Baby Bear puked 3 times yesterday. I didn't go to bed till 11:30. I've been up since 3:10. Yeah. So this might be rough. Whee! Everyone get one? Okay. All right. Do I have a control pair to start law of sines? Nah. So that means I have to use law of cosines to start. And we found out that law of sines can get kind of finicky if it's supposed to be an obtuse angle. Because it won't tell me an obtuse angle, it'll only tell me acute angles. So if I have to start with law of cosines anyway, and if law of sines can get kind of sketchy with obtuse angles, which of these should I find first with law of cosines? Just to prevent any issues. The biggest one, right? Because if anything up here is going to be an obtuse angle, it would be the angle across from the biggest side. Okay? So you could have just done law of cosines twice, subtract from 180, find the third one. Done. Like, not even think about it. But I'm saying if you want to switch into law of sines, if you want to avoid any possibility of that law of sines sketchiness, always find the big one first. Law of cosines likes big angles, and it don't lie. So I'm going to find angle B first. Okay? I'm going to find B first. That doesn't have to be how you did it. It is going to be, the measure of angle B is arc cosine of, treat this as the A, treat these as the B and C, 24.3 squared minus 19 squared minus 21.8 squared, all over negative 2 by 19 by 21.8. What we got? Seven, 4, 3. How votes village? Cool. All right. That also means that if the biggest angle was not obtuse, that means there isn't an obtuse angle. It's an acute triangle. I don't got to really worry about the other ones. So I could go to law of cosines or law of sines for either one of the next two angles, and it don't matter. So depending how you wanted to set it up, depending which one you found first, I could have done measure of angle C by law of cosines again. We do arc cosine of 21.8 squared minus 19 squared minus 24.3 squared all over negative 2, 19 by 24.3. Or we could have done, now that I have one of the angles, I'd have a control pair. I could do law of sines. Say measure of angle C is arc sine of. This is my control pair, so I have that in play. We'll do the control pair with sine of 743 over 24.3, and then the side across from what I'm trying to find, 21.8. Okay, I could have done either one of those. And then about how much? $58 mutter. And that's fine. Like, you should have gotten the same answer though, right? And then I can just subtract from 180 to find my last angle. Say measure of angle A is 180 minus B plus C. Getting about, what's that, 131 and change, so 47 something? Okay. Now I know that you might not have done it in that order, and that's because you could have started with any one of these by law of cosines. You could have then gone to either of the other two by law of cosines or law of sines. So what I'm saying for your pointage is you got one for the setup of the formula of the very first angle by law of cosines. One for the answer with the law of cosines, the first one. One for the formula, something to back up how did I get my second angle, whether you did law of sines or law of cosines. The answer for the second angle, and then subtract from 180 to find your third angle. That's it. So basically 2 for each of the angles you had to really math. And 1 for the, all right, subtract them from 180. Okay? Now, obviously, every bit of this is literally a domino effect. From one to the other, to the other, to the other. What happens if all the way back here I called it 23.4? Right? They all fall down. Do you have the work to back it up? Did you actually follow the process? Did you do all of these things and then you're just a little bit off? All right, one off. Okay? That's why I want you writing the work out, because it allows me to give you full credit for the other stuff. Yes, ma'am? Okay. So law of sines and law of cosines, it depends on what information you're given. In law of sines, I always have the control pair, so I will have either, where to go? Angle side, or I will have angle side. In law of cosines, I'm going to have side angle side or side. If you had both, then you would have four pieces of information. So you'd be able to choose. That won't happen on a quiz. We'll always start with 3 and you have to find 3. Okay? That's kind of how triangles work. You start with 3, you find 3. If they only give you 2, you just host. You can't do anything. And like, but we only had 2 with the right triangles. The right angle is the third piece. Okay? So anything about this? Did y'all feel okay with the formula plug and chug from yesterday? I did want to have an assignment. It's been a rough go of things, so I forgot. All right. Then, homework. That's not homework, that's a review. Starting off with last Friday, we did the other functions. Okay, we spent an awful lot of time on sine and cosine because after that, tangent and cotangent, secant and cosecant just kind of fall into place. So, we're going to practice those. Cotangent. Graph at least 2 periods, labeling your axes appropriately. Again, if you want to label your axes on the graph, I tried to make it big enough that you could. If you want to label them off to the side because that just bothers the living snot out of you, also cool. Okay? Just honestly, my key, I put them in that L because that way it's easier for me to read as I'm checking stuff. What was different about tangent and cotangent phase shift? How do I find phase shift? Phase shift. It's the same. Trick question. Okay. The phase shift is still negative C over B. So my phase shift is just nicely going to be negative pi over 2 over, careful, what's B? 1/4. So negative is positive. Flip the second and multiply. I end up with 2 pi. Okay, now, scrunched eyebrows. The whole lot of you, like, what? Did I just do all of tangent and cotangent wrong? Now, how does period change with tangent and cotangent? Now it's only 1 pi over B. So, period is pi over B. B was, again, 1/4. So that means 4 pi. Now remember, because the period is half as wide as our sine and cosine functions, because it repeats itself twice within a normal revolution of 2 pi, that means I'm not looking for quarter marks, I'm looking for half marks instead. So, that means every 2 pi I'm going to have a relevant feature of these things. Okay? That's not how you spell halves, but okay, I'm just going to roll with it. Halves. So every 2 pi, we're going to have the relevant features of this cotangent graph. We're going to go out to 4 pi, 6 pi, 8 pi, 10 pi, 0, negative 2 pi, negative 4 pi, negative 6 pi, no kitty, my pi, and oh, Frank, come on. Okay, and because 0 was one of my relevant points, if you wanted to keep that in the middle, that's fine. You just have to be careful about where you're starting. Okay, you do still start your graph at the 2 pi because of the phase shift. All right, what about my vertical axis? Okay, there's no vertical shift, so I got 0 at my midline, and the amplitude is 1. Otherwise, it would just be a bunch of dots. Okay, so I'm still going to put 1 and negative 1 here. Then, cotangent. Does it start with an intercept or an asymptote? Okay, tangents start with intercepts. Cotangents start with asymptotes because the reciprocal of 0 is undefined, reciprocal of undefined is 0. So, boop. And then there'll be an x-intercept and a asymptote, an x-intercept and a asymptote, an x-intercept and a asymptote, an x-intercept and a asymptote. In between there, x-intercept, 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 x-intercept. What else was a little bit different of cotangent versus tangent? It's almost a reflection of, well, it is a reflection and a half-period translation of tangent. So each one of these is going to start up at positive infinity and work its way down to negative infinity. The reason I want these 1 and -1 marks on here is because halfway between asymptote and intercept is 1. Halfway between intercept and asymptote is -1. And then try to make it kind of curvy. Don't make it super curvy where it's like a straight up cubic, but try not to make it a line either. Okay. Relevant during Star Wars week. Fly casual. Okay. Dude. Get cultured when they're flying up to Endor. He's like, okay, just act like everything's okay and you're not doing anything shady. But don't look like you're trying to act like you're innocent. I don't know. Fly casual. Come on, this is a celebration of the holiday. You're supposed to watch the original trilogy on May 4th, and then on Revenge of the 5th, you watch the prequels, and then you never watch the other ones. So, good? Okay. Okay, cosecant. Cosecant's the reciprocal of who? Got him. Get at least one person head just whip up into that corner. Cosecant is a reciprocal of sine. Okay. Sine has a vertical shift right here. Has an amplitude right here. Are there going to be who what? Ooh. Dude, I'm exhausted. Word crashed on me after doing updating all of the test forms. So I had to do them all over again. By that point, I was literally cross-eyed and slapping myself. So I was just making up numbers. I don't know what's going to happen. So I'm going to go 2/5 north of that is 3/5. I'm going to go 2/5 south of that, which is 7/5 negatives. Okay, phase shift. Right, 1 and 2/5. 1 minus 2/5. They're just a negative town. Phase shift. Still negative C over B. Dividing by fractions easy as pi, flip second multiply. So negative pi over 18. The period is going to be 2 pi over 6, which is pi over 3, which means my quarter marks, pi over 12. What is the least common denominator between 12 and 18? 36. Okay. So if you need to call this 3/36 pi and call this 2/36 pi, and then as you're adding these increments of 3 over 36, you're going to keep reducing as you go. Be careful. So negative 2/36 plus 3/36 is 1/36 pi over 36. Plus 3 more is 4 pi over 36, reduce it, is 7 pi over 36, is 10 pi over 36. Check me. Don't put pi in there. No, you wrote it as a division problem.
No.
Go to y equals.
I had it like this.
You wrote it as a division problem, not as a
But I
fraction.
have my, it should be in fraction. I just got it. It just
Okay.
takes a second.
Sometimes if you write it as a division problem, regardless of whether it's set up to go fraction mode, it'll still give you the decimal. Use the alpha y equals shortcut to get the fraction, and you'll should guarantee the right thing. Yes, that is the shortcut. Remember, we said phase shift plus quarter marks x, and then go to your table if you want to get the cheater version of all of these and not mental math your way through it. So negative 2 minus 3 is negative 5 pi over 36 is negative 8 pi over 36, which is 2 ninths. Is negative 11 pi over 36 is negative 14 pi over 36 is negative 7 pi over 18. Because 7 and 5 is 12, 12 over 18 is period of pi over 30. Okay. Yeah. That should be right. Okay. All right. So now we go make the dots. This is cosecant. Cosecant is reciprocal of sine. Sine starts at 0, midline. So I will start at midline. And do I head up or down to start the dance? In this case, up. Careful if there's a reflection. Up, middle, down, middle. Down, middle, up, middle. And before I go making my sine curve, I remember, wait a second. You know, you rip the mask off. Wait a minute, it's Old Man Withers. This is cosecant, which means it's the reciprocal. The reciprocal of x equals 0, or y equals 0, is undefined. So every one of these x-intercepts becomes a, oh, we'll just move them. I can do that. Cheater, cheater. And every one of the maximums becomes a minimum. Every one of the minimums becomes a maximum. And you get a bunch of use. You got to throw a little on it if you want the Norwegian accent. Same thing with cosecant and secant. That's one thing I could replicate about my great grandma's Norwegian accent. She always said shoes. Got to tie your shoes. Are we okay with these? If I switched it to secant because I really don't remember what's on the test, are you okay?
Because isn't it just the same thing?
It just starts at maximum or minimum, right? Depending on whether there's a reflection. Intercepts become asymptotes, maximums become minimums of u's, minimums become maximums of u's. Okay? All right. Then we talked about arc functions, and the big thing behind those is that arc functions are restricted. Remember that arc sine, arc cosine, and arc tangent are restricted such that their domain and range are -1 to 1, -1 to 1, for everybody, -pi/2 to pi/2, 0 to pi, and -pi/2 to pi/2. Okay. So we had to remember that arc functions were restricted. Cotangent is a reciprocal function. That's just 1 over tangent. Suppose we probably could have just done that chart earlier to help you remember them a little better. Oops. Y'all, I'm not even joking. It has been 7.5 straight months of averaging 4.5 total hours of sleep per night, usually being woken up 1 to 2 times. Y'all are seeing me at like 50-60% throttle here. I'm sorry. I really am. Oh, got him. Good thing we have a veto today. Yeah. -pi/2 to pi/2, Owen's got it, is parentheses because those are asymptotes. Yes, sir. Okay. With that in mind, where I'm looking on the unit circle, where it's legal to look for things, do these in pieces. Cosine of pi/6, how much? Over 2, right? We made kind of a big deal about this circle. It's got a bunch of writing on it. It would be really helpful right now. Hey! And welcome back. Then, I got to be careful. Arc sine is restricted. Is square root of 3 over 2 a legal value for it? Yeah, it is. And I look in quadrants 1 and 4, where I see a sine value of square root of 3 over 2, and it is pi/3. That's it. Please, I want to give you the partial credit if you do a goof. Write them in stages, because if you goof this part, I want to give you credit for this part. Okay? I was just talking about the restrictions. You don't have to draw the chart. Arc cosine of -1, is it a legal value? Yeah, it is. Huh? Okay. Arc cosine -1, is it legal? Arc cosine -1 to 1. Yeah. So look in quadrants 1 and 2 from 0 to pi. And at -1, no. What angle has a cosine of -1? Pi.
So I don't know if you that. Cosecant?
So cosecant is reciprocal of what? So just do 1 over whatever the sine of pi is. What's the sine of pi? So what's the reciprocal of 0? You can't do that. Okay. Arc cosine negative root of 3 over 2. Who has a cosine value of negative root of 3 over 2? Check which quadrant you're in.
Quadrant 3. So it's in quadrant 5 pi over 6.
Okay. Arc cosine, -1 to 1, that is a legal value. I will look in quadrants 1 and 2 for this ratio. The angle that has this ratio for a cosine value is 5 pi over 6. So 5 pi over 6 goes here. Now do the tangent of 5 pi over 6. This is the same thing as this. Same thing. Arc cosine of a ratio gets me an angle. I'm asking what angle has this ratio? And it is negative root of 3 over 3. All right. Then we started all of our law sines and cosine stuff. I told you that the problems are just going to be, here's information, go. You got to decide what you're using. We covered it all. In triangle ABC, all right, I'm just going to make triangle ABC. I have no idea what this is going to do, and I do mean that literally. I don't remember what this does. B, 55. I'm putting it over in this corner just in case it's one of those double law of sines ones. Like, I just draw my triangles like this because of that, because of the ambiguous case. I'll put B across from it is 20. C is 24, and ruh-roh, Raggy. I have an angle, side, and it's cute. We in trouble. Now, not necessarily two. Remember, it could be a right triangle. It could be one triangle only. It could be two triangles. It could be no triangles. I don't know. If you got acute angle side, you in trouble. It means you got to do the process and hope it comes out okay. So from this angle, I have my opposite. I'm ready to go law of sines. I'm going to go find angle C. I can do sine of 55 over 20 equals sine of C over 24, cross multiply, arc sine that, or I remember the calculator shortcut of measure of angle sine. There we go. I don't remember who. It's only when you're older. No. Panic ensues. Press the buttons, make sure you're in degrees. What do we get? He seems confident. Can the village confirm? Okay. Now, I started with acute angle side side. I did law of sines and got another acute angle. That means, ruh-roh, Raggy, there might have been a second triangle. So I come over here. Okay, we're still going to have 55, we're still going to have 20, still going to have 24, but now we're going to be talking about A prime, C prime, little a prime, because I don't care. I just do that to differentiate. So if I'm talking about A, B, and C up here, you know what I'm talking about. Because it's 55 no matter what. So we'll do 180 minus that for its evil twin. 110.5 something. 100 point something. Okay. I said this whole semester you've seen me about 50-60% throttle. You should have seen the mental mojo before Goblin number 2 showed up. Oh God, yeah. Partial fraction decomp, 4 variable systems in my head before most kids wrote the problem. Like, I'm very smart, but I don't people. But you sport, right? All right. Y'all, I got a... Hey. 100 and change, 55. Be careful. When I said that you might end up with only one triangle, it is possible that I come over here and I get something like 140 as my other angle, but then that wouldn't make sense because it would go past 180. So I just cross this triangle out and be done. Well, I'd go finish that one, but double check that it actually makes sense. And then 100, 55, okay, I got some angle left. Measure of angle A is 180 minus the combination of 55 and C prime is a boot. And now that I have that angle, I can come all the way down here and find itty bitty A, which is again going to be law of sines with this control pair. I've got little a prime is set up control pair, 20 over sine of 55, and then toss in your new guy, sine of 24.415. I swear there's a 1 in there. Now, again, I am writing these as just the calc shortcuts. If you need to write out sine of 55 over 20 equals sine of 24.415 over A. Cross multiply solve. Do it. There's enough space here for a reason. I want you to have room to work that out if you need to. If that's still not enough because you write gigantic, grab a scrap sheet of paper, staple it on, good to go. Okay? About how much is that? Now I still have to come back over here and finish this triangle off. I've got measure of angle A is 180 minus 55 plus original C, which was 55, 80, 134 and change. And then from 180 is 45, 585? Huh.
Yeah. Yep. Okay, come on. Right against the whole thing up there. Actually, it's even 8 hours. It's today.
Pedantic? Yes. All right. That's just dad joke. And then sine of 45.585. What's little a? What's little a?
What is it?
Yeah.
17.
440? Okay, it depends on whether you used the 3 decimal places or whether you kept going with answers.
440, my brain just went
Okay. Yep. Okay. Y'all, you're within a couple thousandths. I said that's going to be okay. Yeah, they do. I think the only people who like significant figures are chemistry teachers.
She's like, you can just round. If you do it on the test, it'll be wrong. But I'm not going to teach it to you. It's really, she's very passionate.
So anyway, I'm going to draw a triangle.
do it.
You know, I bet back in like 1850, 16-year-old kids were learning about significant figures.
So when we're doing this, you do it easier to put the 40 in that one corner so it's out.
I just always draw my triangles with a given angle in that corner because that's how I draw my ambiguous case triangles. It does not. Because remember, b squared plus c squared. Remember that b times c, they're commutative properties. All right, I have side angle side. So I'm going to go find side A. How? Law of cosine says A is 13.9 squared plus 7 squared minus 2 by 13.9 by 7 by cosine of 43.3.
What's that say?
43.3. I ran out of space. I had to squish. I can't just go into the margin like you.
Okay. That is
Square root. Yep. It is a squared, but then I square root for my shortcut so that I can find my answer. What we got? I caught the end part. 100?
That is a goofy triangle. That's not a possible triangle.
So it's 10.0.
Zero who what? Now, I have side, side, side. I can go to law of cosines to find either of the two remaining angles. Or, now that I have a control pair, I'm now able to switch back to law of sines. If I do law of sines, what do I find first? Smallest. Remember, because the big angle might be obtuse and it won't tell me obtuse. I would find C first if I switch to law of sines. In which case, some people just prefer law of sines. If you're going to do law of sines, because there's less buttons, less typing, less writing, then you just have to remember to do the smaller one next. Okay, so there's side and there's 5 side, so it's going to be 10.029 sine of 43.3. Nope. 7 sine of 43.3. Or our cosine of, now that I have all three values, it'd be 7 squared, because now that's my opposite, minus 13.9 squared minus 10.029 squared, all over negative 2 by 13.9 by 10.029. So whether you switch to law of sines or continue with law of cosines, it don't matter. You'll get the second angle. It's got to be smaller than 43. Proportionally, it sounds right. And then I'll just subtract from 180. Good thing I found the smaller angle first, because when I subtract, I get an obtuse angle.
I don't think that's.
It means if I had done B next instead of C, and I had gone to law of sines, I would have gotten the wrong answer. No, because then you subtract from 180 and you'd get that one's obtuse, but that's wrong. Correct. You'd have 3 acute angles that don't add up to 180. Correct. Cosines like big butts and it don't lie. I'm saying you can do both. You can do law of sines if you go to the smallest one first. So what was that, 130 something? 108? Okay. I thought I heard someone say 138, not 108. Now,
Going back to adding ones that aren't really in this category.
I'm going to do it very fast, and you're not going to do it on the test.
It's not on the test, it's a practice.
Y'all got a final in 2 weeks. Okay? Oh, it's on the test. You're just not going to do number 6. You're going to cross it out. I wanted to have it here to remind you, oh, hey, when we did this, that's coming up. That's on your final. When you see rational functions, factor, factor, freaking factor, you remember how to find holes. There is a hole at x equals 3, the 0 of the removed factor. Do you remember how I find the rest of the hole? Not 0. I put the 3 into what is left, and it tells me what point was Thanos snapped out of there. So 5 over 2. So 3 5/2. 3 5/2 will have a hole. 2.5 5/2. Okay. Do you remember how to find vertical asymptotes? Bottom. I find x-intercepts from the numerator. I find y-intercepts by plugging in 0 and, remember it was c over d, the last parts? So a -2 is my y-intercept. And, well, we should. This is Algebra 1. I mean, we amped it up a little bit in Algebra 2, and then we reviewed it in PreCalc. Because the degrees are the same, my horizontal asymptote is y equals 1. Because I only have a single vertical and horizontal asymptote, it's going to have a symmetric property to it. Where, notice that this was over 3 down 1, this was over 1 down 3. So that tells me the rest of it is over 3 up 1, over 1 up 3. Connect the dots. Watch the hole. There you go. Okay? So I just wanted to review it because it's coming. I do have the semester review and the Chapter 7 packets, if anyone wants them for Monday. We're about to do a test, just chill. Okay, you can pick them up now if you want. You can ignore them for a week and a half if you want. I don't care. They will be on the counter and available. Spread yourselves out. Mix yourselves up a little bit.
Okay.
Oh, that's what I did.
That doesn't mean you don't have them, you just don't have it with you.
Holly, ground.
Been ground this before?
Almost like
It's
that.
not.
Thank you.
I didn't look like that. I'm surprised. I love how my
Okay, first, flip it over and cross out 6. If you do number 1 through 5, they're each worth 6 points.